Yes, dear student, the heading is property of electric field lines. Before telling property field line, I'm telling you again, electric field itself is force action positive charge. It means we are telling the property of line of action of force on positive charge. Field lines represent direction of force, and you know direction of force means the direction of acceleration. Actually, when we apply force on a body, force produces acceleration. Please listen to me carefully. F is equal to ma. Why I am telling all these things? Actually, things are misinterpreted by different authors. Electric field lines in one book are defined as the path followed by unit force charge in electric field. That is totally wrong. Why? Because electric field is the force acting by unit positive charge. So direction of electric field we have defined direction force on positive charge, and when we apply force on a body, force produces acceleration, and direction of acceleration is not always along velocity. I keep on telling students direction of acceleration. Actually, vector A is defined as v2 minus v1 upon t2 minus t1. As you people are not my regular students in my class, I keep on telling direction of acceleration is the direction of v2 minus v1. If body moves in straight line with increasing velocity, then acceleration will be along velocity. Okay. And if it is decreasing velocity, it is opposite to velocity. But if body not moving straight line, here it is v1, it is v2. Then you have learnt subtraction of vector. v2 minus v1 is this. So it is like this. v2 minus v1. So direction of acceleration is again along the direction of along change in velocity, difference of velocity. It depends on situation. It may be along velocity, may be avoid velocity, may be at any other angle. In class 11 you have learnt a topic which is very important also, in which acceleration is at right angle to velocity always. There is one important topic in class 11, and that topic says the direction of acceleration is along radius and perpendicular tangent towards center. When body moves circular path, velocity along tangent and acceleration towards center. That is centripetal acceleration. People even don't explain why direction of acceleration, centripetal acceleration towards center along radius, because they are not aware of this fact. People don't apply their brain actually while defining fundamental things. Please take care of the definition. Try to understand definition. Try to understand the concept. Definition of acceleration is change in velocity per unit time. It is a vector quantity. It defines v2 minus v1. So it is totally wrong to say that the electric field lines are the path followed by unit positive charge in electric field. ये बिल्कुल गलत होगा. ये हमारे एनसीईआरटी बुक में लिखा हुआ है क्वेश्चन में कि if we leave a charged particle in electric field from rest or in any manner, then it is necessary that it will move along direction of electric field. तो उसमें wrong लिखा आंसर wrong. It is not always true. if it is left free from rest, then it may move. But if initially electric field is this, and we allow the charge like this, so velocity this way, force this way, so direction, direction force ऐसे होगी velocity, तो it may like this. move like this, not no. So not always true. So properties of field lines. I think what I intend to tell you, कि electric field lines are the path followed by positive charge. This is wrong. Diagonal electric field is the smooth line, continuous line or smooth curve, which are drawn in such a way that tangent at any point with the direction of force from Newton's second law, F is equal to ma. So that tangent will be telling direction of acceleration, not velocity. Here is very difficult, very unfortunate lacuna that we don't understand what is acceleration, what is acceleration and why it is vector. So first property, field lines. Actually, these are the words of NCERT. I am writing as such, or you can see your NCERT book on page 25, volume 1. Field lines starts from positive charge and terminate at negative charge. If there is single charge, if there is single charge, then they may start or end at infinity. They may start or end at if there is single charge. But if it is positive charge, so they will end at infinity. Or negative charge, they will start from infinity. This is the meaning. Number 2. In a charge-free region, electric field lines are continuous lines or curves without break. One year the question was asked, why field lines do not have sudden break? Why do field lines do not have sudden breaks? Field lines do not disappear at once, suddenly. Why? Because field lines start from positive charge, terminate at negative charge, or if field lines are broken at any place, it means field becomes zero. And field is zero at infinity. So electric field line cannot have sudden breaks. Number 3. Two field lines can never intersect. If they do so, it means there will be two directions of electric field. Why I say if anyhow they intersect like this. So here tangent is this, here tangent is this. So a field cannot have two directions. And a system of charges or a single charge or many point charges around it has one magnetic electric field. Field cannot be two at any point. So field line can never intersect. I mean, if they do so, there are two directions of electric field, which is not possible. कुछ भी कह सकते which is absurd or two field are not there. Because you have seen अगर भाई field क्या है ये यहाँ पॉजिटिव चार्ज है पॉजिटिव चार्ज है इस पॉइंट पर इसका the force is this way and this way तो resultant one तो field line like this ये जो field line है ऐसा हो जाएगी तो field lines can never intersect. Now last property which is very important here to understand. Questions are asked on fundamental things in every exam, whether competitive exam or board exam. But we don't understand how it is so simple. Electric field lines. Electric field lines do not form closed loop. Closed loop. Magnetic field line make closed loop, but electric field lines do not make closed loop. If you see the field due to dipole, this terminate here, this come here, this go away, but never it is like this and go this way. So field line do not make electric field line do not make a closed loop. And here they say this is due to the conservative nature of electric field. Or you can say since electric field is conservative, so field line do not make closed loop. Now, but surprisingly, you don't know what is conservative force or conservative field. So please, if you don't have this in your mind, please learn here definition of conservative force. Conservative force. Problem is that you people are told this is not in syllabus. Something are indirectly involved with us. What is involved with us, then we have to learn it ourselves, whether it is syllabus or not. For example, logarithm has been deleted from the syllabus, but you get you see log involved in somewhere like integration, integration dx upon x, equal to log base ex. So you have to learn log itself yourself. So many things are there. I keep on telling. So what is conservative force? I am writing definition, please you write. If work done by a force or against the force in carrying a body, if work done by a force or against the force, if the work done by a force or against the force in carrying a body from one place to another, does not depend on path followed. Then the force is called conservative. Generally, teacher asks this question in exam. Define conservative force. Children are so shortcut. They apply such a shortcut that force which does not depend on path followed. Force nahi, not the force, but the work done does not depend on path followed. So our electrostatic field is conservative in nature. That is why the field line do not make closed loop. Work done, I will be telling you, work done in electric field for a closed loop 0. Other example, gravitational force is also conservative, and the fields where such force exists are called conservative field. So electrostatic field, gravitational field, magnetic field, they are conservative field. Electric field produced by rest charge, I told you, is called electrostatic field. There is another source of electric field also. We will learn in chapter of electroinduction. That field, electric field, is a varying magnetic field. It is not conservative. So now, what is the use of field lines? Actually, in our learning or understanding the subject, we use field lines to represent electric field. If electric field lines are parallel and every two adjacent lines are equidistant, then it is uniform electric field. This is uniform. If closer the field lines, this is a field line. Another field is written here like this. Here field lines are parallel, but the distance between them is smaller than this. So this E1, suppose it is E2. So here E2 magnitude is greater than E1. Closer the field line, stronger the field, and farther the field line, weaker the field. And you know, field due to point positive charge, field lines keep on going away from each other. What does it mean? Field lines are like this. So when we are going away, field lines are going, distance between them increasing means field is decreasing. So farther the field line, weaker the field. Closer the field line, stronger the field. If it is, field lines are like this, distance decreasing, it means field is weaker here, stronger here. Or we can say field is increasing in the direction of electric field. If it is like this, then field is decreasing, just like this, as you move, but arrow must have. So these are the uses of electric field lines. Please read books and listen carefully and try to understand calmly. I have noticed students are in very much hurry. Today I have revised 2 chapters. No revision home. That is simply you have turned the page in very fast speed. And when we learn very fast, we don't grasp the thing. Once you have grasped the thing, people say, students say, sir, I forget. Actually, to forget means you are healthy mentally. Who does not forget, he is sick by mentally. So, I think it is sufficient about electric field lines. Now I will take in next video the torque on dipole in uniform electric field.